So can you say that again, what you did?
Yeah, so I mean, I guess then what you would said it was a CSTR, but we did C out equals C in times Q in over Q out to find the concentration of each section.
No, well, you're still sort of treating it as a CSTR where you really don't need to do that. You've got a continuous mass source, which once it's distributed through the whole system, you'll have the same sort of mass flux everywhere.
Okay. Okay.
So I think you're overthinking it a little bit because the only thing that then determines the concentration is how much water there is.
Okay.
Right? So if you've got a set mass, you know how much volume you have.
Okay.
That'll give you the concentration. I should say mass over time, and you've got a volume over time, right?
Mm-hmm.
So just using those two pieces of information, you can get your concentration.
Okay. And then for question 4, for the CSTR, the equation that we used was C out equals C in all over 1 plus KV over Q to find the concentration, and then the concentration in changes each time as C out changes. And I was just wondering if that was the wrong approach.
I don't think it's right. I didn't hear the equation when you said it, but it sounded like the right approach.
Okay. The equation I just said it was C out is equal to C in all over 1 plus KV over Q.
Yes.
Okay. Okay, and I think that's all the questions I had.
Okay.
Thank you.
For our equation 4, we have C out equals and then C in, but we have it minus then KV times C times V over Q. Ours is
all right. I could write this down because I can't have trouble keeping
Sorry.
So let me just point you to, if you go to chapter 7.
Yeah.
Like equation 7.42 is basically what we're dealing with here, right? This is a steady state solution to CSTR. You should have your mass loaded over the outflow plus KV.
Oh, so we need the mass flow instead.
And Camilla, I'm not sure if that's what you said. Seemed like you said you just had the concentration in the numerator, but it should be probably concentration times flow.
Okay, yeah, I just had the concentration in over all of that.
Yeah, I don't think your units would work out then.
Okay.
But make sure you double check the units to make sure they are.
Okay, yeah, because that's the equation I used. The concentrations aren't varying at all.
The concentrations aren't varying?
For V out or C out, but they're like really minimal variations.
Well, they should be varying. I mean, it should look pretty similar to what you had in part 2. So, especially in that first reach, you should be seeing significant changes in concentration.
Okay.
So you start at like 0.15 milligrams per liter, right?
Mm-hmm.
And by the end of the first reach, you should be down to 1.1.
Okay.
What are your K values?
My K values are 0.97, 0.4 for the second stretch, and then 0.19 for the third stretch.
Yep.
Okay.
Those are all right. Yeah, so I think just check your mass balance then, because it should be able to see significant decay within the reach.
Okay.
What were those Ks again that were supposed to be?
Oh, ballpark 1.4.2. It can be a little bit bigger.
1 point what? 4, you said?
No, the first one should be about 1 per day. The second one should be about 0.4 per day, and the last one should be about 2 per day.
We're like a little bit higher, like 1.22, is that?
It's possible. That seems kind of. You mean for the first stretch?
Yeah, for the first stretch, and then like 0.5 for the next stretch.
It's so you know, because they depend on K sub A, there can be a little bit of variability in how you dealt with that. Those seem kind of high though. I guess I'd be suspect that you didn't do your temperature corrections.
Okay.
I mean,